Good afternoon. My name is Daniel Moreno. I am an undergraduate student and I am currently working in the group on the writing of a review about mineral waste valorization on heterogeneous catalysis. Scope of the presentation that I am presenting today, we initially see the introduction and I will approach this on the motivation for this review, and from there we will start deepening towards the applications and research opportunities that the group has on this field. First of all, we must understand that the tools that humanity have used along the years come in a very big proportion from soil and mines. Extractivism is always an irreversible, impactful human activity, and therefore, as technology grows faster and faster, we must find ways to mitigate these environmental impacts. The most basic way to mitigate these environmental impacts is first of all trying to make it worth and useful every cubic centimeter of land and earth that we take from the soil. On this approach, some investigations have been made for applying mineral waste recoveries for the production of construction materials and also geopolymers. Research field that's more related to the group is geocatalysis. This is a term coined by Schoenen et al. And it refers to the utilization of mineral-based catalysts for the replacement of other synthetic catalysts that may be more expensive. And the main goal of geocatalysis is to find mineral materials that are equally effective than those synthetic catalysts in applications like pollutant remediation, air quality improvement, chemical synthesis, waste valorization, and others like hydrogen production and carbon capture. Now that we know that mineral wastes can be applied as heterogeneous catalyst, we want to focus on one mineral specifically, or one kind of mineral. This is the black sands. Black sands are kind of aggregates that are specific for having the black color and granular morphology. Black sands are commonly composed by high content, high iron content uh, mineral phases like ilmenite, hematite, magnetite, and it is common to find black sands as mineral waste on extractivism applications like gold or silver mining. There are already some well-established fields in which this kind of mineral wastes, the black sands, have been studied as heterogeneous catalysts. The first I am presenting here is advanced oxidation processes. This is a kind of reaction in which an organic pollutant in water is decomposed non-selectively into more environmentally safe wastes. This kind of reaction usually uses an oxidizing agent, mostly hydrogen peroxide, and a source of UV radiation. And in this case, this will mean that this is a photocatalyzed reaction. And some relevant reports that have been presented on the literature already use minerals like rutil, hematite, and ilmenite that are present in black sands as a for the remotion of this kind of pollutants that you can see in here that are mostly dyes. Well-studied research field in which heterogeneous catalysts have used black sands is chemical looping combustion. This is an innovative process to maximize the energy efficiency in fuel combustion. In this case, those minerals are used as oxygen carriers. This means that the catalytic process takes two steps. The first step includes the combustion of the mineral of the fuels in presence of the mineral, and the metals are going to reduce in the reaction. And in the second step, the metal is oxidized in presence of air. This kind of process increases the efficiency of fuel conversion into carbon dioxide and water. Applications that have been less studied and therefore less reported are, first of all, the catalytic reduction of tar in biomass gasification. This has some few reports in which ilmenite has been used to improve the efficiency of gas production in pilot scale gasifiers. The second study that I report here is the catalytic refinery bioelectrification. Uh, this is a research field that has a few reports in the literature. Very well. We have come very quick until here, so I want to summarize what we have reviewed in this presentation that is also about a review. First of all, mining is a very impactful human activity for the environment. It is mostly irreversible, and therefore it is a big challenge to make it the less damage to environment as possible. Uh, this is why some research fields have developed the focus on valorizing mineral wastes, such as construction materials, geopolymers, but mainly, or most important for us, is geocatalysis. This means that we have already a big research field that we can work in that is divided as well in more specific fields that are advanced oxidation processes, chemical looping combustion, for example, that are the most studied fields. These kind of fields uh, remain unexplored avenues that the group can work in, but we also have seen that there are some other research fields that have been way less explored, and this is also an interesting scope for the group to develop research in those fields, because it has great opportunities for fill those research gaps that already exist. And that's been all for my side for today. I thank you very much for your attention. I hope this was interesting for you, and I'll be pleased to reply to the questions you may have by email if that's possible. And that's it. Thank you very much.